to be learning something called the modulus and the argument. And basically, like the arguments and the modulus and argument, it really reminds me of like vectors in a way. Like if you guys learned vectors last year, you learned can't think. You learned about like magnitude and the direction. So the modulus with vectors, it's like the magnitude. And remember, the magnitude was the distance, the length of that line segment. So the modulus, if you remember from vectors for last year, just think it's like the magnitude. And then the argument, like the vectors, the argument is like the direction. So magnitude let us know length, and the direction, that was talking about the angle measure from the positive x-axis. Okay. So it really ties into the vectors. So if you, and we do the exact same. We find the argument and the modulus the exact same way you would have found them last year with vectors, the way you found the magnitude and the direction. So, but we're doing it modulus and argument. This terminology is used with complex numbers. Complex numbers are things that can be written in the format a plus bi, so imaginary numbers. So like if I had, say, 3 plus 2i. And a lot of the times they'll let the letter z represent that complex number. So z is just something that can be written in the format a plus bi, a real number plus something with an imaginary number. Okay, so if you're given an imaginary number, a complex number, let's say 7, you can write 7 as a complex number because 7 could be written as 7 plus 0i. So all your real numbers you're used to working with are complex numbers. We can graph these, and this is considered the x-axis that we always called the x-axis. That's your real axis. This capital R with 2 lines means real, but if you want to, you can write the word real. The y-axis is I. That's your imaginary axis. So if I wanted to graph 7 plus 0i, it means I go 7 real, and then 0 imaginary. So it just stays right there smack on the real line. If I wanted to graph, say, 3 minus 2i, well, I go over 3 with the real, and then down 2 with the imaginary. So over 3, down 2. So you're kind of graphing it like x comma y, where the ordered pair, it goes a comma b, when you have it in the format a plus bi. So you can think of the real part like the x value, the b part like the y value. If I wanted to graph negative 3 minus 3i, or negative 3 minus, let's go 2i, I would go 1, 2, 3, down 2. And then if I wanted to graph, say, negative 3 plus 4i, I would go left 3 and up 4. And then if I wanted to graph just, say, 5i, that's like saying 0 plus 5i. You would just go up 5 on the imaginary axis and no real part. Okay, so that's the basic of graphing a complex number. So if you're given a complex number and it says find the modulus in the argument, you can graph it first so you know where it's at. So like this ordered pair that they have labeled P, let's say that they wanted you to graph, let's say it was this one, negative 3 plus 4i. 1, 2, 3, and 1, 2, 3, 4. So that's negative 3 plus 4i. If they gave you that ordered pair only, or that complex number only, and they said, what is its modulus? The modulus means basically what is its length. So what you do is you're finding its length from the origin. So if I wanted to find the length between P and this origin, what would I do? Yeah? Okay, so Pythagorean theorem is going to work. If you make a triangle, and always make the triangle to the x-axis. So once you've made that triangle, I can do a squared plus b squared equals c squared. Or sometimes we'll call this r for like a radius, because like sometimes we deal with like circles. I'm just going to call it r for radius. So I know that this squared plus that squared equals r squared. And that 3 in the format a plus bi, the 3 is my a, the 4 is my b. So I could say a squared plus b squared equals r squared. And then I would do the square root. And so then I have r equals the square root of a squared plus b squared. So you don't have to sit always and write it out in Pythagorean theorem. You can just immediately start by putting a square root and then take whatever your a is, which in this case is -3, square it, plus take the b, whatever it is, square it. So -3 squared is 9, 4 squared is 16. That gives me 25, and then the square root of that is just 5. So then I know my modulus, my length from the origin to the P, is 5. 5 is my modulus. Now to get the argument like in vectors was like the direction, and you found the direction by finding the angle. So when you find the angle, you find it from the positive x-axis. So from here to here, that entire angle, whatever that is going to be the argument. Now, I can just look at that and know it has to be greater than 90 degrees, but it also has to be less than 180 degrees. Now, when I want to find that angle there, I kind of find it indirectly. I could first find this angle inside the triangle that I drew, and once I find the angle inside the triangle, if I subtract that from 180, then I'll have this other angle. So if I wanted to find the angle inside this triangle, how would I find that? Yeah, tangent was correct. Tangent is opposite over adjacent. Because it's a right triangle, we can do the SOHCAHTOA. So then to find my argument, I'm going to say tangent of that, I'm just going to call that angle theta because I don't know what it is, equals opposite, which is 4, over adjacent, which is -3. Now, when you want to find an angle measure, that's where you do the inverse. So to find out what theta is, I would do inverse tangent to both sides of the equation, and then I'll have theta equals inverse tangent of 4 over -3, and then this is where I said you have to have your calculators today. So you make sure you're in degrees, which I already checked at the beginning of class that I was, and then I just go inverse tangent of 4 divided by -3. Now, my answer that I get out for tangent, I told you guys when you do things in the calculator, inverse tangent only gives you answers between -90 and +90. So this one gives me -53. So what that -53 is saying is it's saying the angle from here to here is -53 degrees. But this one right here would be positive 53 point whatever. Okay, so it still gave me like this one right here. So since I know that this angle is the 53 degrees, if I wanted to find this other one, I could just do 180 minus that 53. Or since this is already negative, I could say 180 plus this answer up here because it's already negative. So then I know this part of the angle is 126.86. And that's what I'm calling my argument. So my modulus is 5. My argument is 126.86 degrees. Okay, so we have some formulas we need to make sure we know because you're just going to be using these formulas over and over and over and over and over and over on this assignment. You have to have these formulas down. Okay, so again, the z is just the notation we use for a complex number, something that's in the format a plus bi, so like 5 plus 3i or whatever they choose to give you. If you need to graph it, you graph it like A is the x value, B is the y value, and you just ignore the I because the I lets us know we're in the complex plane and the y-axis is like the I. If you want to find the modulus, you just use this formula R, which is representing the radius or the hypotenuse when you make your right triangle. Okay, so R is like that hypotenuse. You just do the square root of, then square the A plus square the B. Now, if your A or B is a negative number, make sure you put it in parentheses and put the square outside of the parentheses, because it should come out as a positive number when you square a negative number. Or you can just drop the negative and square it, because either way it's supposed to come out as a positive number. And then to get the argument, it's going to be tangent on every single one, because the A and B are going to make the two legs of the triangle, right triangle if you draw it in. And then so it's always going to be B over A. So inverse tangent of B over A. And then it says then convert to the correct quadrant, because again, inverse tangent will always give you an answer between negative 90 and positive 90. But you don't always want to be in the first and fourth quadrant. Sometimes you want to be in the third quadrant or the second quadrant. So you have to, whatever answer you get from the calculator, then convert it over into whatever quadrant you need. Okay, so this one right here, number 2. Now, I didn't mention this, like these absolute value signs, that means modulus if it's a complex number. So a lot of the times you might see find this right here. That just means find the modulus. So that's what we're going to do. So my A, I'm just going to off to the side. Remember, it's A plus B I. So my A is negative 5. My B is negative 5. I'm ignoring the I, because I don't use the I in any of my formulas up here. Now, before I quickly find this, I'm just going to graph it, because I think sometimes graphing helps you to make sure you're in the correct quadrant. So if I were to graph this, I would go negative 5 to the right, and then I would go down 5. So this is the point that I'm doing. So when I come up with my argument, I'm going to want to end up with an angle that would get me into the third quadrant. So it's going to have to be an angle greater than 180 degrees. Okay, so that's just a way to check the reasonableness of your answer. So then if I were to construct a right triangle, you always draw it up. Whoops, my board's way off, but you always draw it up to the x-axis. So this distance, negative 5 and negative 5 there. And then the theta that you're finding initially in the calculator is that part right there. Okay, so then when I do this, I want to find the modulus. That's what absolute value is saying. The distance right here, the distance from your point to your origin. That's what your modulus is. So I just do the formula, R equals the square root of A squared plus B squared. So my A, so negative 5 squared plus negative 5 squared, because the B was also negative 5. Negative 5 squared is 25. So I end up with 25 plus 25, which is root 50. And then root 50 has a perfect square. That's the same as root 25 times root 2. So I could say my modulus is 2 root 5 because, sorry, 2 5, yeah. 5 root 2, thank you. I said that backwards. Root 25 is 5, and then the root 2 stays in. So that's my modulus. Now I need to come up with the argument. So the argument, I know I just have to plug it into this formula, inverse tangent B over A. Again, the reason I'm doing this formula is because if I look at this right triangle, tangent is opposite over adjacent, which would be negative 5 over 5, and then do the inverse, so you get the angle measure. So I'll go theta equals inverse tangent of negative 5 over negative 5. Negative 5 over negative 5 is the same as 1, so I could just in the calculator go inverse tangent of 1. Whoops. You could even look on your unit circle and find the two places on the unit circle where the sine cosine value are the same, like root 2 over 2, root 2 over 2, because that would be a 1 also when you divided them. So I know the answer is going to come out as 45 degrees because I know my unit circle. But if I didn't know that, you could type it in. Now I know that this angle, I know the argument really wants the angle from the positive x-axis all the way over to here. So that 45 degrees that I just got right here, is just the angle right there. But I need the whole angle, so what do I need to add to 45? 180 is correct. So, whoops. So plus 180, or you can just look on the unit circle and see what angle's right there, and it's 225. So I know that my argument is 225 degrees. So try number 8. We're doing the exact same thing. We're just going to find the modulus and the argument. And again, I'm just going to quickly sketch this graph to make sure when I come up with the argument, I get it in the correct quadrant. So if I were to sketch this, 8 would move me like this direction, so I'm just going to call that 8. Negative 3 would then move me down 3. So I know that I have to end up with an angle that would get me all the way into the 4th quadrant, which means my answer for my argument has to be an angle between 270 degrees and 360 degrees, because that's the angle that gets me into the 4th quadrant. So I'm not done if my theta isn't between 270 and 360. Okay, let you check your answer. Okay, but I'm going to start with the modulus. So the modulus, right here, I'll just say for my modulus, I'm just going to say M for modulus, R equals A, and there's my B. So I say R equals root, I do A squared, so I go 8 squared plus, and then B squared. 8 squared is 64. Negative 3 squared is 9, so I get root 64 plus 9. Add those together, I get root 73. And then there's not a perfect square that goes into 73, so then I just leave it like that. If you want to, you could type that in the calculator and get the decimal number. Now, to get my argument, I'm going to say A for argument. I have to start with this formula right here to find theta, and then after I get theta, I again know that on the calculator, inverse tangent will only give me an answer between negative 90 and positive 90. I know I need an answer between 270 and 360. So after I get the answer from the calculator, I'm going to have to add or subtract something to it to get it into the quadrant I need. So I'm going to go theta equals inverse tangent of B, my B was negative 3, over the A, which was 8. And then just type it into the calculator. So negative 255, sorry, negative 20.55. Now I know that's not my answer because it's not between 270 and 360. So negative just lets me know that they went clockwise around the unit circle instead of counterclockwise. So they figured out this angle right here to be negative 20.55. I want the angle that starts here and goes around that way. So what could I do to find the other angle? Yep. So I could add 360. I could add 360 because this is negative and it will take it away. So add 360. And then I get 339.44. So my argument (339.44 degrees). There's my answer for my argument. There's my answer for my modulus. Okay, I want you guys to try number 10 first, and then I will work it out after you've had a chance to try it on your own. Okay, so for 10, you should have first, like I would have roughly sketched it and knew that negative 4 would be over here, and then positive 10 would have been up here. So you should have been in the second quadrant. So then when you come up with your argument, you're going to have to get an angle that's between 90 and 180. So you know your angle has to be between 90 and 180. If it's not, then you know you either didn't finish it or you messed up somewhere. Okay, but I'm going to start with the modulus. So my modulus The r, I just say is the square root of a plus bi, so I just take the a, negative 4, and square it, plus do the b, and square it. Negative 4 squared is positive 16. 10 squared is 100. So then I end up with root 116. And then I saw some people type in the calculator and have 10 point whatever, which is fine. I chose to recognize that there was a perfect square that went into root 16. If you divide it by 4, you're left with 29, yeah. So you also could have said the modulus was root 4, which is 2 root 29. So that's the answer in radical form. You can't do them separate. Yeah. Now to get the argument, that's where we do the theta equals inverse tangent of b over a. My b was 10, my a was negative 4. So I just type that into the calculator. And I get negative 68.19. Now that's not my answer because that's not an answer between 90 degrees and 180 degrees. So what that told me is that the angle negative 68 would have been right here, which meant that that corresponded to this angle right here being 68.19. So now how can I find the angle from here to here? Yeah. Yep, subtract that from 180. Since this number is already negative, instead of doing 180 minus this, because then it would turn to a plus, I can just go plus 180. And then I get 111.8. So my argument is then 111.8 degrees. Yeah, so when you do number 1, if there's no number in front of there, it would just be a 1. So try that one before I work it out. Okay, so for this one, let's just start with the modulus. The modulus you guys seem to not have the problems with as much. The modulus, A is 7, your B is negative 1. So we do 7 squared plus negative 1 squared, which is root, and then 49 plus 1, which gives me root 50. Root 50 is the same as root 25 times root 2, so it becomes 5 root 2. So 5 root 2 was the correct answer for the modulus. Okay, the argument. This is where a little bit more problems. So tangent theta is b over a, so negative 1 over 7. So negative 1 divided by 7. Okay, so that negative 8.13 that a lot of you guys got, you have to know the quadrant because this isn't the angle that we need. We have to then convert it to the correct quadrant. So this 7 minus I, if I were to graph it, here's my real, here's my imaginary. I'd have to move right 7, and then you have to move down 1. So you don't actually have to like sit and put all the little tally marks and have it graphed in the correct spot exactly. You just have to know you go right and then down. So I'm in the 4th quadrant. That means I have to come up with an angle for my argument that's between 270 degrees and 360 degrees. Negative 8.3 is not between 270 and 360. So what that negative 8.3 is the calculator gave me the angle from the x-axis this direction. It went clockwise and told me that that angle is the negative 8.13. But I want the angle that starts on the x-axis and goes counterclockwise. So what am I going to do to get that angle? Plus 360. Yeah, because it's already negative 8, so if I add 360 to it, I'll get the rest. So if you're not in the correct quadrant, you're either going to be adding 180 or 360 to get into the quadrant that you need. So add 360 and 351.86. And 351.86 is a number between 270 and 360. Okay, so the bottom part is dealing with something that's called polar, like the little add-on instructions I put there. It says then convert to polar form and graph. The polar form is where you like graph on that circular one that's down there. Okay, so first graph each complex number in the plane, then convert to polar form. So if I wanted to graph this, I would go to -1 on the real and then up 5 on the imaginary and just put your point. So when you convert to polar form, polar is where you're graphing with like these circles. Polar form has, instead of this A comma B, the ordered pair for a polar is R comma theta. And that's why previously on the problems, like when you guys were finding the modulus, that's why I specifically said R equals. It's the same thing. I find this R using the exact same formula that I was just barely using up above. R is just going to be the square root of A squared plus B squared. The exact same thing. There's nothing different. To get the theta, the angle, I'm using the exact same formula. So I'm converting to something called polar form, but you convert the exact same way we did the previous problems. The R, because these are circular, the R is representing the radius, but you still find the radius by like making a right triangle and doing A squared plus B squared equals C squared or R squared. To find the angle, it's still the same thing because, yeah, it's all the same. So then to find this one to convert, I'm just going to find my R. So to get my R, I just say the square root of my A is -1. So -1 squared plus the B, which is 5. So then I get root 1 plus 25, which is root 26. So my R is root 26. Okay, to get your theta, I just do inverse tangent of B, which was 5, over A, which was -1. But like the other ones, you have to make sure you're in the right quadrant. So we still have to check and make sure we end up in the correct quadrant. So inverse tangent, 5 divided by -1 is just 5, so I'm just going to type in inverse tangent of -5. So I get -78.6.
Okay.
Now, there's several different ways. There's more than one correct way you can do ordered pairs with polar. Okay, unlike coordinate planes where there's only one answer that's going to get you into that specific spot. Polar, there's could be an infinite number of ways you can list those angles to get you in that same spot. So I'm going to show you, like on my answer key, I have 2 ordered pairs listed for each one, but you could get more than 2. So I'm just going to show you how you can come up with 2, but you guys only have to get 1, okay? So continuing what we were doing on the previous assignments, I need to come up with an angle that's in the second quadrant. -78, that's the angle that would go this direction into the fourth quadrant. So basically, I found this angle right here is -78, which means if I brought it up to here, those lines are not at all straight. I found like the angle right here would be the 78. But I want the angle from here to here. So what would I do? I want an angle between plus 180, yeah, because I need an angle between 90 degrees and 180 degrees. So add 180 to that, because I can just add 180 because the angle was already negative to begin with. 110.3. I'm sorry, 101.3 degrees. Okay, so then my R, my R was root 26. So now I'm just putting it as an ordered pair, R comma theta. So root 26 comma 101.3 degrees. So when you graph polar, what the R does, that 26, root 26, that's like 5 point something, 5.09. When you graph polar, what you do is I usually graph the radius, or I mean the angle first. So what you do is you find where 101 degrees would be, just approximately. So you look at the unit circle, and 101 degrees would be between 90 degrees and 120 degrees. So you'd put like 101 degrees, like maybe about right there. So you just kind of approximate where it would be if you just look on the unit circle. So it would be 101 degrees would be about like, whoops. Oh, you tried to do it. Sorry, I can't even draw a straight line on my board. But you put in about where the angle is. And then once you have about where that angle is, and I just draw it as a straight line, then what the R tells you, it tells you how many circles out you need to be, because each of those circles is 1 radius. Okay, so then since root 26 is about 5.09, that means I need to be just a little bit past the 5th circle. So you just count out 5 circles, 1, 2, 3, 4, 5, and then you just put a point where 5.09 would be. And then notice that ordered pair, where that ended up graphing, is in the same position as the one over here. So when you're graphing with polar, you just graph where the angle would be, and then count out how many circles your R is. Now, I told you with polar, there's multiple ways you can write it. I could have written this angle, this ordered pair out, using that negative 78.6. I could have said my angle was negative 78.6, which would have put my angle, it being this angle right here. But I didn't want my point to be over here in the 4th quadrant. I wanted it to be in the 2nd quadrant. So with polar graphing, if you make your R negative, it pushes you away, backwards. So if I'm here in the 4th quadrant and I want to get to the 2nd quadrant, I can do a negative R and it pushes me backwards into the 2nd quadrant. So I could do negative root 26 and it would still be that point there. So if R is positive, you move towards the angle. If you use a negative R, move away from the angle. I want you guys to try number 14. So it boils down to finding the R and the theta. Just think like the modulus in the argument that you're doing up above, only with this is now like the radius and the angle measure. So the polar coordinate graphing is similar to finding the modulus in the argument. Okay, so what you should have had for your R, your A was 4, your B was 4. So you should have did the square root of 4 squared plus 4 squared. So 16 plus 16 is 32. And then you could do the root of that and have the decimal number, or you could have said, well, that's the same as root 16 times root 2, which is that of 4. So then you could have had 4 root 2. To get the theta, you would do inverse tangent of B, which was 4, over A, which was 4. 4 over 4 is 1. So I can type it in the calculator, but I know that answer is 45 degrees. Okay, now I'm going to quickly graph this because we want to make sure we end up in the correct quadrant. So if I graph 4 and 4i, 1, 2, 3, 4, 1, 2, 3, 4, this is in the 1st quadrant. So I know my angle measure has to be an angle between 0 degrees and 90 degrees. I got an angle between 0 and 90, so for once I don't have to do something to my theta. Okay. It's only if it doesn't land in the 1st quadrant that you have to modify it. So then I know actually right away what my polar coordinate should be. Polar coordinate is always R and then theta. So my polar coordinate should be 4 root 2, comma, 45. So I would go on the circular graph, I would go to where 45 degrees would be. Right there's 45 degrees. And then the 4 root 2 as a decimal, this one you really need to kind of know what the decimal is. 5.6, is that what you're saying? Okay. So that lets me know I have to be between the 5th and the 6th circle because it's more than 5 but less than 6. So I just count out 1, 2, 3, 4, 5, 6. So about 5.6 would be almost halfway between the 2 circles, and you put a point. So now when you compare this with the coordinate plane over here, those 2 points are roughly in the same spot. And they should be in the same spot if you really did convert correctly.